Hey guys, how's it going? We are going to be constructing regular polygons inside of circles. You need to have out in front of you your pencil, compass, and a straight edge. If you don't have something like that, go ahead and get them out. You need to pause the video until you have those items. Alright, so some vocabulary terms before we get started. Okay, a polygon is a figure with at least 3 straight sides and angles. So a polygon with 3 sides would be a triangle, a polygon with 4 sides would be a quadrilateral, polygon with 5 is a pentagon. Okay, now a polygon can be regular or irregular. Regular means that all the sides and all the angles are of equal measure, like here in this picture. Irregular means that the sides are different lengths, they're not the same. Alright, so the question is it a polygon? So taking a look here, first off, this is a polygon, has straight sides, and is closed. Okay, this is not a polygon because it has a curved edge. And this is not a polygon because it's not a closed figure. If I were to connect this, obviously that would be a straight line there. If I were to connect that, then it would become a polygon. There we go. Alright, so looking here, we have several different types. Remember, 3 sides is a triangle, 4 sides is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 sides is a heptagon, 8 sides is an octagon, 9 sides is a nonagon, and 10 sides is a decagon. Alright, just as a refresher, okay, and also a 12-sided figure is a dodecagon. Okay? Now here's what we've got here. We need to construct an equilateral triangle inside of this circle. First things first, you need to draw a diagonal. Remember, a diagonal goes from one side of the circle to the other and passes through the center. Okay? So there's my center, one side to the other. Now you need to get your compass out. And what I want you to do is I want you to measure the radius. So from one point here to there. Now what you are going to do is you are going to create an arc through the center of the circle that passes your circle twice. Once and twice. These are going to be the first 2 points of your triangle. Okay, then you're going to connect this point here, and the point where the circle meets your diameter, the one that we did not use to draw the purple arc. When I connect those 3 pieces, there, to there, to there, I have an equilateral triangle. Now I also want you to be familiar. Sometimes you may be shown a question, but, let's not do it that way. I'm going to group them. And it may look like this. Okay? You need to be able to be familiar with if it looks in a different direction, or maybe this way, or maybe this way. Okay? So occasionally I will show you different pieces and ask you, what is starting here? What is beginning? So if I were to delete the extra pieces like this and said, what is happening here? What is the beginning construction here? You would need to be able to tell me that you are constructing an equilateral triangle inside of a circle. Alright, so what we have here this time is I would like to construct a square inside of a polygon. Okay, now it says a regular quadrilateral. Now, quadrilateral is 4 sides that have all 4 sides the same length and have all 4 congruent angles. So I guess it's not quite a square. It could also be a rhombus. Okay, but we're going to construct a regular quadrilateral. First things first. Given the center P, draw a diameter and label it AC. Okay, it could be anywhere. Then what you need to do is you need to do the perpendicular bisector through through line AC. So remember, open up your compass to more than halfway and create your arc. Do the same thing from point C. Remember how to create a perpendicular bisector? This is exactly what we're doing. Alright, so put your compass away, and what you're going to do is you're going to connect the two intersection points to make your perpendicular bisector. So let me get a ruler out here. And let's connect this. There we go. Now the place where where this purple perpendicular bisector meets the circle we called B and D. So now all we have to do is connect A, B, C, and D to get our regular quadrilateral. Okay, now if you take a look here, this is actually in fact a square, and when we talk about inscribed angles, you'll get to see why. Basically, angle B here is 1/2 of 1/2 of a circle, so 1/2 of 180 is 90. Alright, so don't worry about question number 1 for now. Let's discuss question 2. It says, the regular quadrilateral in activity 1 is inscribed in the circle. What is the relationship between the circle and the regular quadrilateral? Basically, if you have a shape inscribed inside of a circle, that means that the circle is circumscribed about the quadrilateral. So that's number 2. Number 3 says a regular octagon is an 8-sided polygon that has 8 congruent sides and 8 congruent angles. Using angle bisectors, construct a regular octagon from a regular quadrilateral. Basically what we would do here is we would bisect angle APB. And when we cut that in half, so let's go ahead and do that. I'll get a different color. Okay, remember when you're bisecting an angle, you create an arc, and then from that arc create 2 arcs in the interior. So and there. Then what we would do is we would connect point P through there. So now instead of having 1 line here, this would actually be 2. So every side would basically be doubled. So instead of a 4-sided figure, we would have an 8-sided figure. Okay? So let's write that here. Alright, so we have drawn an equilateral triangle, a regular quadrilateral. Now let's do a regular hexagon inside. Alright, so the first thing that we need to do is put a point on the circle, and we're going to call that point A. Then you open your compass to the width of the radius and put your pointer on A and make a mark that crosses the circle. Do this over and over, so move it to the next one. Keep making your marks. Try to be as precise as you can. And then when you get to the last one, it should be precisely on your point A. So now all you have to do is connect everywhere that your arc intersected with the circle. So connect each of these vertices. Alright, there we go. And what we have here is an inscribed regular hexagon inside of a circle. Alright, now, how can we justify that this is in fact a regular hexagon? Okay, well first off, we had the same compass setting when we marked all the way around. Okay? Now it says, go ahead and draw diameters AD, BE, and CF. So let's go ahead and do that. I'll get a different color line here So we want to draw AD, so A should have been directly across from it there. Then it wants us to draw BE, so they're opposite of each other. I did not label these like I should have. So why don't I go ahead and label these? B, C, D, E, and F. Okay, if you look here, we have formed 6 different equilateral triangles. Okay, that tells us that we have created a 6-sided regular hexagon. Now number 5 says a regular dodecagon is a 12-sided polygon that has 12 congruent sides and 12 congruent angles. So just like what we did before, when we changed the quadrilateral to an octagon, we can change our hexagon into a dodecagon by bisecting each angle. Alright, so then all we have to do is connect there. So our new side would be here to here. And if we did that to each angle, it would separate each of the 6 sides into 2 sides, making 12 sides for a dodecagon. Alright, so we need to measure each of the angles in the polygon for activities 1, 2, and 3. Now, we did not do the construction of the pentagon, so we will just go back and look at the equilateral. Now, the equilateral triangle, the sum of the measures is 180. We know that all triangles add to 180. So if we divide them by 3, that means that they each must be 60 degrees. Okay, looking back at our regular quadrilateral, okay, we can go back here and measure our angle. So let's measure angle D. Put your point there. Make sure it lines up with 0, 0. And we have 90 degrees. Do the same from point A. Vertex at 0, 0. Okay, line up your other side. 90 degrees is angle A. So all 4 of these angles are 90 degrees, which means they must add to 360 degrees. So let's go back to that. So we have 90 degrees here and 360 degrees. Alright, so we are going to go and look back at our regular hexagon. Okay, here is our hexagon. We need to measure each of these angles. So I'm going to get my protractor out. Alright, so let's put this on angle A. Okay, because remember, a regular hexagon means that all the angles on all the sides are the same. And I need to line up side AB with the 0 degrees. I measure it, and I get 120 degrees. Okay, remember this is obtuse, not acute, so you don't have 60. So that would be 120, which means it adds up to 720 degrees. In a pentagon, each of the angles of a regular pentagon is 108, and the sum is 540 degrees. So what is the general rule for finding the sum of the angles within sides? Basically, okay, notice it's going up 180 each time. 180, 360, 540, 720. And depending on the number of sides depends on how many degrees it adds up to. So what you would do is 180 times the number of sides minus 2. So 3 minus 2 is 1, times 180 is 180. In order to find each individual one, you take the sum and divide it by each number of angles. Now the number of angles is the same as the number of sides, so you just do 180 times n minus 2 all over n. Alright, I will see you guys later.